All right, guys, welcome to 8.3. This is going to be simplifying trig expressions. We're also going to be verifying trig expressions. So in order to do this, you have got to utilize your identity sheet. You'll want to have that out as you're working. I'm going to write notes on the identities up at the top, and then we'll begin to simplify. So let's start with the Pythagorean identities. We have sine squared x plus cosine squared x is equal to 1. Now from there, we know that sine squared x is equal to 1 minus cosine squared x. I'm just taking this original and moving things around. We also know that cosine squared x would be equal to 1 minus sine squared x. All right, we also have 1 plus cotangent squared x is equal to cosecant squared x. And you can find these on your identity sheet. This is all there for you. We're just going to rewrite it in multiple ways. 1 is equal to cosecant squared x minus cotangent squared x. And then cotangent squared x is equal to cosecant squared x minus 1. We also have tangent squared x plus 1 is equal to secant squared x. We have tangent squared x is equal to secant squared x minus 1. And then we also have 1 is equal to secant squared x minus tangent squared x. Feel free to pause at any point to make sure that you get those down. I'm also going to write the quotient identities up here. I'm going to move back just a little bit so we can make sure to get all of that in the picture. And then I'm going to get up for a second to make sure that the light comes back on. All right, I'm going to write the quotients and the reciprocals here on the side. You will want to use those as well. Again, if you have this sheet out, that's going to help a lot. We have that tangent x is equal to sine x over cosine x. And then we have cotangent x is equal to cosine x over sine x. All right, and then we have our reciprocals, which you guys should know, but it definitely helps to have them here to refer to as you go through. So we have sine x is equal to 1 over cosecant x. We have cosine x is equal to 1 over secant x. We have tangent x, which is equal to 1 over cotangent x. We also have cotangent x, which is equal to 1 over tangent x. And then we have cosecant x, is going to be equal to 1 over sine x. And then we have secant x, which is going to be equal to 1 over cosine x. All right, these are going to come in handy throughout. So we're going to be simplifying these expressions into much more simpler versions of writing the exact same thing. And we are going to start with the first one, and you'll just kind of get a feel for it as we go. So you're going to be changing something in this expression to match one of these. And my advice to you is that whenever you're given 1 over cosine x times 1 minus sine x squared. Well, how can I make these combine? They have to be the same at some point. So I need to find a way to make one of either turn cosine x into sine x or take sine squared x and turn it into cosine somehow. And I'm going to start with the one that's in parentheses. We have 1 minus sine x squared, which is right here, and it's equal to cosine squared x. So I'm going to use the 1 minus sine squared x is equal to cosine squared x. I'm going to use this and replace it in this expression. So I have 1 over cosine x is, not equal, times cosine squared x. And technically that's over 1. All right. Once I do that, it's also cosine squared x over cosine x. And this is technically the same as writing cosine x times cosine x because it's cosine squared x over cosine of x When you do that, and hopefully that helps you see that you're going to cancel those out, this is just a fancy way of writing cosine x. So this entire expression up here is really just a funky way of writing cosine x. All right, let's move on to number 2. And again, you will find that there's actually multiple ways to solve these. I have already found more than one way to solve some of these, more than 2 ways to solve some of these. So if you are creative and you find a different way, but you still get the same simplified answer as you should, then that is absolutely fine. All right, so let's start with this one. We have cosine x tangent x minus sine x cosine squared x. All right, so what I am going to do is get rid of this tangent because we have cosine, sine, cosine, but the tangent I'm going to get rid of. And tangent is the same as sine x over cosine x. So, and again, like I said, there are several different ways to solve these. You can change different things and still end up simplifying and getting the same answer, and that is okay. So we have technically cosine x times, what was it? Sine x over cosine x. Minus, same thing, sine x squared cosine squared x. Well, when you take cosine over 1 and multiply it by sine over cosine, those cosines cancel out. So we're left with just sine x minus sine x times cosine squared x. All right, this is where things are going to get a little trickier. You can use the greatest common factor in order to simplify this in a different way. So sine x minus sine x times cosine squared x. So what if I pull out sine x? Then I would have 1 minus cosine squared x, because then if I were to factor this back in, it would be sine x minus sine x times cosine squared x. So I pulled out that sine x, and we're left with 1 minus cosine squared x, which is sine x squared, as we see up here. So I'm going to rewrite it again, which is sine x times sine squared x, which is a funky way of just saying sine cubed x, so which is just sine x times sine x times sine x. All right. Let's move on to number 3. We have 1 minus cosecant squared minus cotangent squared. And let's see what happens when I just see if this is up here, which it is. We have cosecant squared x minus cotangent squared x, which is right here, and it's equal to 1. So if this is equal to 1, and we have 1 minus 1, that's 0. All right. And our last example of simplifying trig expressions here. So we have tangent squared x over secant x minus 1. Let's go ahead and change it to, let's change our tan squared x. That is equal to, I'm looking up here, by the way, secant squared x minus 1 over secant x minus 1. And if it helps, one thing is going to be a flashback here. If you remember, x squared minus 1 is the same as writing x plus 1, x minus 1. All right, so using anything squared and then it's minus 1, sometimes you can find it up here, but you can also factor it. So this is the same as writing secant x plus 1, secant x minus 1, all over secant x minus 1. Once we do that, oh, and there's supposed to be an x in there, my bad. Those cancel out, and we're left with just secant x plus 1. All right. That is going to be simplifying. I'm actually going to write a couple little more notes here. Just remember greatest common factor. So if you have something like x minus xy, you pull out that x and you would have 1 minus y. So just for future reference, this is an example of us starting to simplify trig expressions.